It's a production-ready foundation that you can extend with template engines, database integration, or WebSocket support. Understanding how web frameworks work from the inside out makes you a better developer and gives you the confidence to build lightweight services without depending on heavy frameworks. You've built a complete web micro-framework from scratch. This single Java class implements routing with path parameters, static file serving, middleware filters, cookie management, redirects, exception handling, and JSON serialization. An after filter adds an X powered by header to every response. The custom exception handler returns a friendly HTML error page with the exception message. After all configuration, app start launches the server, and the program waits for the user to press enter before calling app stop to shut down gracefully. The main method creates a mini Spark instance on port 8080. It configures static file serving from a/public directory. It registers a global before filter that logs every incoming request with the method, path, and client IP. This demonstrates how middleware can inspect and potentially reject requests before they reach route handlers. The toJSON method provides basic JSON serialization without any external library. It handles null, strings, maps, converted to JSON objects, and lists, converted to JSON arrays. For unknown types, it falls back to calling toString, and wrapping the result in quotes. The escape JSON helper escapes backslashes, double quotes, and control characters. This is not a full JSON library, but it's sufficient for API responses and demonstrates how serialization frameworks work internally. This gives real-time visibility into every request the server handles. The sendResponse method writes a complete HTTP response to the output stream. It handles redirects by writing a status line with the location header and skipping the body. For normal responses, it writes the status line, content type, content length, connection header, server header, any custom headers from the response object, a blank line separating headers from body, and then the body bytes. It also prints a color-coded console log entry, green for 2x, yellow for 3x, red for 4x and 5x. The serveStaticFile method normalizes the path, constructs the full file path, checks the static file cache, and reads the file from disk if not cached. It determines the MIME type from the file extension, sets the response content type and body, and sends the response. If the file doesn't exist or is a directory, it returns false, allowing the normal route matching to continue. The cache ensures that frequently accessed files like CSS and JavaScript are served from memory. Fourth, all after filters are executed. Finally, if any exception occurs during processing, the exception handler is called. The processing pipeline has 5 stages. First, if static files are enabled and the method is get, it attempts to serve a static file. Second, all before filters are executed. If any returns false, processing stops immediately. Third, the framework searches for a matching route by iterating through all registered routes and checking with matches. If found, it extracts path parameters from the regex matcher and calls the handler. If no route matches, a 404 response is set. Finally, it builds a request and response object and begins processing. The handleConnection method is the heart of request processing. It uses try-with resources to manage the socket, a buffered reader for input, and an output stream for output. It parses the request line to extract the HTTP method and full path. It splits the path at the question mark to separate query parameters, URL decoding each key and value. It reads headers into a map by splitting on the colon. If a content length header is present, it reads the exact number of body bytes. The start method creates a server socket on the configured port, sets the running flag, prints a startup message with the URL, and submits a task to the thread pool that loops accepting connections. For each accepted socket, it submits another task that calls handleConnection. The stop method sets the running flag to false, closes the server socket, shuts down the thread pool, and waits up to 10 seconds for active tasks to finish. This is the standard lifecycle for an embedded HTTP server. The framework exposes simple methods for registering routes: get, put, delete, and patch. Each creates a new route entry and adds it to the routes list. Filters are registered with before and after, which add filter functions to their respective lists. The exception method replaces the default exception handler. Static file sets the folder path for serving static assets. This API is intentionally minimal and expressive, mimicking the style of Spark Java. The main server class holds the port number, a thread-safe list of routes, lists for before and after filters, an exception handler, a path for static files, a server socket, a cached thread pool for handling connections, a running flag, and an atomic request counter. The constructor initializes all these and sets a default exception handler that returns a 500 error page with the exception message. This design separates configuration from runtime state cleanly. We create a static file cache using a concurrent hash map that maps file paths to byte arrays. This avoids reading the same file from disk on every request. A static MIME types map provides correct content types for common web file extensions including HTML, CSS, JavaScript, JSON, images, fonts, and icons. The cache is populated lazily. The first request for a file reads it from disk and stores it, subsequent requests hit the cache. Converting prefixed segments into capturing groups that are later extracted during request processing. The route entry class stores a single route, an HTTP method, a compiled regex pattern, a list of parameter names extracted from the path, and the handler function. When a route like /users/id/post/post ID is registered, we convert it to a regex and store the parameter names ID, post ID. The matches method checks if the request method and path match. This is exactly how Express and Sinatra handle dynamic routes. We begin by defining the foundational types. An HTTP method enum covers get, post, put, delete, and so on. The request class encapsulates everything about an incoming HTTP request: the method, path, headers, query parameters extracted from the URL, path parameters filled by route matching, the request body, and the client's IP address. Headers and query parameters are stored in immutable maps for thread safety. The response class holds the status code, content type, custom headers, response body. Today we're building something ambitious, CSS, a complete JavaScript, JSON framework inspired by Spark and icons. This single Java class will handle routing with path first request for a file static from disk and process before and after filters, hit the cache, manage cookies, redirect converting prefixed segments into capturing groups that are later extracted during request processing. Under the hood, the route entry class stores a single HTTP server with a cached thread pool, a compiled regex pattern, a list of parameter names understand how web frameworks like Express, Flask, and Spark itself actually work, because you'll have built one from scratch. Post